Hi everybody, I want to start derivative in mathematics. Derivative is a function when we have a limit and the limit function, and when we have a function of a plus h and we minus with the main function and divide h, it is a derivative if the h goes to the zero. Okay, but then we can say derivative, we can show derivative with f prime x is very easy, and it is a theoretical part of derivative. It's very easy. And for example, I show in the graph, for example, if I have a function like here I draw is fx, okay, or fa because it is in the graph is a, okay. And when we have a two function, we have a fa and the other one a plus h, and this distance is the h. It will be a plus h, okay. When we go this a plus h go to the a, in this situation h become almost zero, then these 2 points will be closer each other, and then in the end will be the same point. This will be the derivative in the function. There are many ways to write the derivative. We can show with the derivative function in the theoretical dy per dx or df per dx. Usually we show with a d, okay, and but it must, if we cannot write function is here because it depends how is the our function. For example, if my function is the y equals 3x plus 3, in this situation I can write dy per dx will be derivative of x, in the y it will be 3, okay. But we cannot write, for example, fx equal 3x plus 3 and the df per dx is not good because we don't have this situation. Okay, for example, here we see the derivative of the x2 minus 3. If we, in the parabola, we find the derivative, okay, it will show the maximum or minimum points. For example, we know one of the formula of derivative. If we have a fx equal x power n, in this situation f prime x will be n x n minus 1. It will be, in this situation, will be f prime x will be 2x, and the 3 is the number and derivative of number is 0. But if we want proof for theoretical part of the exam, because in the final exam we usually have the theoretical, in this situation we have to add some number. Instead of x, we have to be x plus h power 2 because the power 2 is here, and the minus 3, and then we have to minus the base function and divide for h. As you see, if we open this function, will be, if we open this function, will be x2 plus 2hx plus 2h2, okay, minus 3 minus x2 plus 3 divide h. Now I cancel each other as I show you, okay. Minus 3 go with plus 3, minus 6 go plus x, and the result will be 2hx plus h2 divide h. And then I can factor from the h, 2x plus h divide h cancel each other, and f prime x will be 2x plus h. I know the h go to the 0, then f prime x will be 2x. It is very easy way to find how we can calculate. It's very important. And this point of 2x, it shows our maximum minimum if we 2x equal 0, x equals 0, x equals 0, exactly the point of the our maximum or minimum x. And if we put x instead of x minus 3, 0 here, it will be y equals 0 minus 3. In this situation, it will be y point. Then I can write here y equal 0 minus 3, y equal minus 3. It will be then our x is 0, y is the minus 3. It is at this point, which is a minimum. Okay, but if we want to also draw the f prime x, we can show it is a linear function. And then derivative of the function is a function of the differentiable if it has the derivative everywhere in its domain. It must be continuous and smooth function and closed interval, must have one side derivative defined at the end of the point. For example, it's very easy. As you see here, to be differentiable, a function must be continuous and smooth derivative will fail to exist. For example, here it is a corner. Okay, it is a, we cannot make a derivative because it's not continuous and smooth. And as you see here, we can do because it is a continuous and smooth. Okay, we cannot do this and we cannot do this. Okay, and we can do this also. Then it's very important. And as I mentioned, when the h go to the 0 in this situation, we can find the slope line in that point. In the intermediate value is the derivative if a and b in the any 2 point, and we go from the b to a or a to b. Okay, and this line will be in this situation, it will be limit. Okay, of this function, and between a and the b, f prime must take one every value between the a and the b. Okay, then in this situation, if we have, for example, f prime of this point will be exactly for this point of function, and f prime of b, if the same will be for this point. It shows how much value we can put in here. For example, I can explain very easily. Our if x, it is a, for example, x power 3, okay, plus 2. And I found f prime x, it will be 3x2, okay, because number will be 0. And I put f prime r. Instead of x, I put r, one number, for example, okay. For example, -1 or -1, okay. 3 times -1 power 2 will be plus 3, okay. For if I put, for example, plus 2 will be 3 times multiply 2 power 2, it will be 12. Okay, as you see here, in both of this situation, we can find, okay, every point have its y value, and it depends for how much we can find it. Okay, for example, here our y value is plus half. Our y value is just plus 3. For example, if we have a function, for example, for this function, if I found f prime x 3, because it is it is a function, is like a number power 3, for example, 3 power x. Okay, as you see here, f prime is 3 power x. In this situation, if we put x number, for example, we find half here. If we use a logarithm from here, logarithm to this one, logarithm of the 3 half equal x, and we can find the x point from this value. And first formula for the practice, please remember, this is the first formula. If we have every function in the power n, we have to -1 in the power and send to minus n behind the derivative. For example, for x, we have to send 4 behind the send 4 behind the number, and 4 minus 1 will be 3. 8 we have to send here, and 8 minus 1 will be 7. It's very easy. You can do it, for example, fx or y. Okay, 2x 4. In this situation, we have to write 2, multiply. We have to send 4 here. In this situation, multiply 4. And x, 4 minus 1. 2 times 4 is the 8. X power 3. It's very easy. It is the base power rule, and we have to know this formula, and it usually comes in the practice. You can see here. And for the, as I mentioned, for the proof is very easy. We have to add some number first here and open the minus the base function, and then simplify and divide in the h, and find the result will be derivative function. Okay. It is the second rule, is the like first rule. If we have a number behind the derivative number, in this situation we put the number behind the x, and we send n here. We have to multiply c plus multiply n, and we decrease the power 1. For example, 7 must be here, 5 I send here. It will be 7 times 5 is 35. And the power of the 5 minus 1 will be 4, will be 35x4. If we have another rule, the second constant multiple rule, and the sum and the differentiation rule, if we have some of the functions, each one we have to make a derivative. For example, x power 4 plus 12x. First, the 4 come here. Decrease power 1 will be 4x power 3, and because it is 1, decrease 1 will be 0, and will be, we cancel x, will be 12. Okay, we have 3 here, again 4 behind, and decrease power 1, 2 behind, 2 times 2 will be 4, and power decrease 1, and number derivative will be 0 because no x here. Okay, you can see here, and 4 come here, and decrease power 1 will be 4x3. 2 come here, 2 times 2 minus 4, and decrease power 1 will be x. It will be our derivative. Okay, if we make equal to the 0 this derivative and find the x, we find this x point will be horizontal tangential line, because it's very important. And when we find this x point is very important. If we put x in the y-axis, okay, here in the y, the main function, we can find the y. For example, if we put 0, 0, 0 will be positive 2. If I put minus 1 power of 1 is the plus 1. Minus 1, it will be minus 2, plus 2, it will be this number. And if a positive 1, also positive 1 powerful, minus 2 plus 2, again will be this one. This is the horizontal line, horizontal tangent line of the function. For example, here, if you see, it is a graph I showed you. The point I found it minus 1, it is a derivative equals 0, 0 equal, and plus 1 equals 0. This is the derivative point. And if we put these points in the main function, we can find y-axis, you see, and we can find 3 points. The 2 of them minimum and 1 of them is maximum. It's very easy. Then I can say for you, it's very, very important. And then if we have a function, for example here, y equal for x power 4 minus 2x2 plus 2. If I have a y prime or derivative will be 4x3 minus 4x, and this y prime equals 0 shows here in here maximum or minimum or inflection point. Here we don't have inflection point. And if we put these numbers, okay, instead of in the function, main function, we can find the y-axis point of this maximum or minimum or inflection point. Okay, it's like here. For example, if we draw, also we can draw a derivative function again. It is the first one. I draw here, and it is a derivative of this function. I draw here. As you see here, in the derivative point, if you see in the maximum minimum, always shows how the change in the next time I will show you. For example, in the function go down and go up in the maximum minimum, okay? Go down is the negative and the go up is positive. Then in the derivative function from the negative go positive. Okay, because as you see, I write here, it is go down and go up. Go down is the negative, go up positive. It shows from the negative go to the positive because it is at the same point. Okay, the second one, go up, go down, then positive, go to the negative, positive, go to the negative. Or here, go down, go up. Negative to positive, okay, negative to positive. As it's very important. It is we can find also predicate the function. It's very, very important for us. Okay. If we have some function, multiply function. Okay, for example, two functions multiply each other. U multiply V. The derivative is very easy. U multiply the derivative of the second multiply derivative of first. It's very easy. If I have this function, it's very easy. First time I multiply this for derivative of this. Okay, it will be this. This is the derivative. Okay, because I write the same here and I multiply this. I make a derivative of this, multiply to each other. And again, I write this one. Okay, multiply the derivative of this. It's very easy. I can write easily if we have a if we have a uv, then derivative will be okay. U multiply v prime is plus v multiply u prime. This sign shows the derivative sign. Okay. And sometimes we can prove it very easily. For example, if I multiply this number and open the parentheses, I can find this equation and then I make a derivative from all, and then but the result will be the same. What we can show you. It's very important for the proving, okay, but it is for the final exam, okay, we can use this system. Okay, how is it possible? Again, when we use, for example, uv equal u multiply v prime plus v multiply u prime, in the v prime derivative part, we have to write again the same. Okay, v, okay, x plus h minus vx divide h all together multiply to u, and the second one also we have to write u x plus h minus ux and divide h. This part for the final because it is very important. In this case we have to find the systems, very important. And if we have a divide, it's very important. It is a new rule. If we have a u per v function, it's very important. First, we have to u prime, derivative of the upper function, multiply lower, minus derivative of lower, multiply upper, divide lower v, it is a v, power 2. It's very easy. I can do here for you again. As you see here is the rule. Derivative of this will be this. It is a derivative. Because 2 times 3 x power 2, 5x will be derivative as 5. Multiply the lower function. Minus derivative of this, 2x, 3 number derivative as 2, multiply the upper, divide lower part power 2. Then we can make simplify. It's very easy. And very easy we can find the result of this function. Then until here we learned many functions about this. And how about the proof we can show you is very easy. I can show you what we learned. If we have a multiply, two function, we say uv will be u v prime plus v u prime, okay? If you have a divide v u prime minus u v prime divided by v power 2, because here the between will be negative. It must be very important. And it's very easy, and we can find the number very easily, and we can put the number here in the function, and we can find the derivative of the or slope of the function. Okay, and this example we can show in the velocity, because we know speed, it is derivative of the distance per time, and acceleration is the derivative of the velocity, or we can say per time, or we can say the derivative of the distance, 2 times derivative of distance will be acceleration. Okay, for example, here we can see here very important, or we can in the European we can write meter per second. Okay, as you see here, it is the acceleration is very important, and meter per second power 2, because it shows the second derivative of the time in the distance. As you can show here that the same rule, acceleration is the derivative of velocity, and the velocity is the derivative of the distance per time. As I mentioned last time, okay, if we have a increasing or decreasing, if it is a distance per time, you see here with the increasing, okay, and we can have a more possibility, as I mentioned last time. If we have a derivative of this curve, we can find the acceleration, and we know if the acceleration positive here, acceleration is 0 because the inflection point, acceleration is a negative because, and the acceleration is 0 because inflection point, and the velocity is 0, and we can go down. Is very, very easy, important for this. Velocity and run rate changes, as I mentioned, we can show with the functional of the fx plus h minus fx. As I mentioned, the base, we can show here with the base rule is very important. For example, in the distance, we have we know the, for example, x is the distance, and the time is the, for example, second. Okay, if we have a dx per dt, excuse me, it should show velocity, and dv per dt shows acceleration. It's very important. And the other important, the sinus and the cosinus derivative, or derivative of the trigonometric functions. Okay, derivative the sinus will be cosinus. If we have a sinus, derivative will be cosinus x. And if we have a cosinus x, derivative will be minus sinus x. It's very important. You have to memorize this number in the angle we have from the minus pi, okay, and minus half, 0 plus half, pi per 2 and pi. Okay, minus pi, it means minus 180 degree. Minus 90 degree, 0 degree, plus 90 degree, plus 180 degree. Okay. We can prove, you don't need to memorize the proof, but for sinus, I write for you. If we have a fx sinus x, we can find f prime x. It is a cosinus x. It is very important. I can show you how, because we add the h for the function and minus the initial function, and we open the function, but you don't need to here memorize, but for in the advanced situation you can memorize it. And in the situation and in the end is sinus 6 multiplied cosinus h, sinus h cosinus 6 minus sinus 6. Then we can factor from the sinus 6, we can find this situation. And as we know, for example, because it's h, it will be 0 here. Okay, In this case, we cancel each other, this one, and we can find just the cosinus 6 remand, because this will be cancel each other, and we have to find just cosinus 6. Okay, it's very important. And as you see here, I showed you, because this cancelled will be 0 and will be cancelled, this one becomes 0, and this one will be 1 and will be 1, and there will be cosinus 6 is the result of the sinus. But I write here I show here cosinus derivative will be minus sinus 6. It is I write for you, okay, if we have a f of x or y equal cosinus 6, and the derivative will be minus sinus 6. Okay, you can see here. And for tangent, we can write 1 per cosinus power 2. If we have fx equal tangent x, in this situation, f prime x equal 1 per cosinus power 2x. If we have a cotangent, will be, if we have a fx cotangent x, in this situation f prime x will be minus per 1 sinus 2 power x. Is very important. It is the other one we can find for the cotangent. And also we can find it's in the derivative of the acceleration. And second change in the acceleration, we can find some change rule. It is a very important function. Usually our teacher or professor speak about it when we have a two function, okay, or we can say chain function or composite function. For example, how is it possible? For example, if I have a y is this function, okay, and u is this function, what is about this 2u is very easy. We can put, instead of this function, we have to do this function. It shows when we want to calculate the derivative of the y in the index, we can find derivative of the u in the y, multiply derivative of x in the u, and the result will be the same. Okay, y derivative will be 6, y 2u derivative will be 2, and u it will be 3. If you see the multiplied 2, it will be the same number. Okay. It is one of the rule in the, usually in the exam come, what I said for you, if we want to find the derivative of the chain rule or composite function, it shows the derivative of the f prime, okay, jx, derivative of the composite function, multiply derivative of the inside function. For example, fx, we have the sinus x, jx is this one. Now we want ask us to find the f prime, okay, of these two multiply function. Okay, it's very easy, and we can find the sinus is the cosinus, x2 is the 2x, and we put multiply 2 behind each other. Okay, will be the function of this our system. Okay. For example, I do this function with you, but in the simple form, okay, with the hand. Okay, fgx is this function. I write for you fjx equal f prime jx multiply j prime x, okay? What is the f prime jx? Derivative of this function, okay? Will be cosinus, sinus will be cosinus x2 minus 4. Multiply j prime x, it means derivative of the x2 minus 4. It will be 2x, then I put 2x here. Then I can say derivative of the this will be this, derivative of the this will be this. And the result will be multiply these two numbers. It's very, very important to have to solve this question. Or I can do this one again. We have it, if in this situation, f jx is this one, and the jx is the x2 minus 4. Then I can write f prime jx equal derivative of the first one will be cosinus x2 minus 4, and derivative of the jx will be multiplied 2x, and will be result will be do this. And we can put a number and we can find the inflection in the other point, slope point also. It's very, very easy. Also, we have this function. I want to do this for you. Cosinus 3x power 2. It is a f prime jx, f gx, and for the jx it is 3. First time I find the derivative of this will be the number 2 comes behind. Cosinus x will be cosinus 3x, and inside it will be sinus 3x, and the sign will be negative. Why? I will show you formula. U prime equal u prime un, if we want to find the derivative of un, okay, will be n multiply u prime multiply u m power minus. It shows first we find the derivative of this inside it. N must come behind, and n minus 1 go here. For example, I found this one for you. 2 must come behind. Cosinus derivative will be minus sinus, and decrease 1 power will be this. Or I can make a color. This number go here. Cosinus power 1, 2 minus 1 will be cosinus 1. Okay, cosinus 3x. And inside derivative of this will be sinus. Again, this will be green because the derivative. Decrease the power will be this, and the number n go behind it is this. As you see here, as I explained it for you, very easy, important rule. When we want to find the derivative, if we have a power, we have to find also the inside the function derivative. For example, here also the same situation, but we don't have a function here. We have just find fjx here. We have to find derivative of here. Okay, cosinus derivative will be minus sinus 3x plus x multiply jx is this one. Derivative will be 3 multiply 2 multiply x power 2 will be power 1, and the x derivative will be 1. Then derivative of this will be this one. I can make a color. Derivative of this will be this one. Okay, it will be derivative. And the derivative of all this function will be this one. Then result will be minus sinus 3x plus x multiply 3 times 6. 3 is the 6 plus 1. It's very easy, and we can find this derivative rule, and it's very easy. And the result is here. You can find this result here. Or second example. We find the first derivative of the sinus. Cosinus x will be cosinus, because we find that this derivative will be cosinus x. And inside cosinus derivative will be minus sinus x. Then you can derivative of this, it is a derivative. And the total derivative of this function will be cosinus this total. It's very easy. Also here, but here is different because why? Because we have a power here. Again, we have to find 3 times cosinus power 1 decrease 2 4x3 plus 2x multiply cosinus derivative will be minus I put here minus 3 sinus 4x 3 plus 2x. It is a derivative of the f prime jx. And the second, we have to multiply the derivative of this one just. Okay, derivative of 4x3 is 4 times 3 multiply x decrease power to 1 power decrease will be x power 2. It will be 12x2 and plus 2. The result will be this one. As you see here, you can find this rule here. But then we can multiply, simplify, and if we simplify, will be the same result. But it is this until here is okay. If you do this, this answer is okay. You don't need to continue until the simplify. Now you understand the chain rule and how we can find it and how we can find it. It is very important. What our professor said is we can find the f prime jx equal multiply j prime x. We can find the derivative function of the f jx. It is a very easy form, and we can find for this new rule. And also we can see here the other example. Okay, and we have again chain function, but they are in the 2 forms. We can find it very easily. Okay, cosinus will be derivative will be 3 minus 3 times sinus, because cosinus derivative will be minus sinus, and the 3 become behind, and sinus will be cosinus, and it will be because they are together, and we can find the f prime x, again the same situation. And we don't need this part because it is differentiation rule, but it is more advanced. It's more explanation about this. Sometimes we have, for example, no functional rule. For example, we have a circular, and we have this x2 plus y2 equal 1. It can be circular or eclipsed. And we can do this derivative rule to find the point on this curves, which is not function. Okay. And the last step as the implication point, it is for the non-functional, like eclipse, like circle, and these forms. And it is very important. Also, I explained about theoretical. I explain it again. E power x exponential curve. If we have exponential curve, okay. If we have an inflection, if we have a derivative and equal 1, always pass from the positive 1. It will show the equation of the derivative here. And you have to know, if we have a fx equal e power x, derivative of f prime x, always the same. But if we have a f prime x, if we have a e power u in this situation, okay, it will be different, because we will have a 2 again f prime jx, okay. And in this situation, we have to write u prime e power u. Okay. And then we can find the rule the same. The answer, derivative of e power x will be the same. As I show you, e power u, again, we will have a e power u multiply derivative of the u. In this situation, I write the easiest form. E power u derivative will be u prime e power u. For example, e power 3x, we have to write derivative of the 3x. It will be 3, and e, we write the same e power 3, multiply e power 6. Or other example, it's a harder example, e power e power sinus x. Sinus x derivative is cosinus x, then multiply e power sinus x. Then we have to find that this is the derivative of this, and then the other one will be the same. And if we have r power x, very important, very, very important, then we have to write r power x again and multiply ln a. For example, if we have a function of the 2 power x will be 2 power x, derivative will be 2 power x, multiply ln a 2. It is very important. Okay. If we have a RU, okay, then if we have a RU, we have to write, if we have RU, it will be U prime, derivative of the power, multiply, okay, RU, multiply, ln R. I write example, 3 power sinus 6. Okay, first I have to write U prime. Sinus derivative will be cosinus 6. Okay, multiply. I have to write R power U, the same function. 3 power sinus 6. Multiply ln R, ln 3. E power U, I have mentioned, will be U prime E. Again, I write for you. E power U will be U prime E, E power U. For example, E power x2 will be, first I have to find derivative of x2 will be 2x, multiply E x2. It's very easy. But for the IU, for example, 5 power x2, we have to write derivative of x2 will be 2x, same 5 power x2, multiply ln 5, okay. And derivative of ln u will be 1u multiply derivative of the u. Ln u, derivative will be u prime, multiply 1 per u. For example, ln sinus 6 will be sinus 6 derivative will be cosinus 6, multiply 1 per, what is the u? Sinus 6. You see, very easy. This sinus go down, 1 per u. We cancel ln, and derivative cosinus will be here. If we have a logarithm with the au, it is very better if we have a logarithm here. For example, if we have a logarithm 10, for example, sinus 6. First, we have to find 1 per, okay, function is the sinus 6, multiply ln of the base. Ln of the base is the 10, multiply derivative of the sinus will be cosinus 6. Then I can write formula, log ur, derivative will be 1 per u multiply ln a multiply u prime, derivative of u is very, very important formula. Then we can, again I show you, e power u will be, derivative will be eu multiply u prime, but it is also u prime, meaning r power u equal ru multiply ln r multiply u prime, derivative of u prime, ln u equal 1 per u multiply u prime, logarithm r per u equal 1 per u multiply ln a multiply u prime, will be the same example. You can find some example I will show you very easily. Again, is e power u is very easy. U prime multiply the same. It is the same function. Multiply u prime is this one. Then I can say it is a u prime I can show you it is a u prime, u derivative of u, and then I have to write all the same here. But here is different because I have to write strip of the same multiply ln of this number multiply x derivative of x2, it will be 2x, and ln x3 derivative, and 1 per u is here x power 3, derivative of x3 here, derivative of x3 is x4, and will be result after simplify. And also we can have this simple questions. And now you understand how we work it. And here we have a y equal x power x, ln y is ln x per x. It is a derivative of logarithmic function. We can find the derivative of y per z where x in this situation from both of this, and we can find the result here. And I hope it will be good. And the next time I try to solve some question about derivative, and in this case we can have more information about derivative. And see you, have a good time.